Okay, so now we're going to go through proportional relationships part 2. We're going to start with this scenario right here. And it says the student council is selling t-shirts to raise awareness for the local animal shelter. For each t-shirt they sell, they will donate $7. So through this scenario, whenever we wrote our verbal description, we used unit rate. So that's what we're looking to pull out from here. What is the unit rate? So for each t-shirt they sell, they will donate $7. So first off, the first thing that we're talking about here is t-shirt, and the second thing is $7. So your unit rate is 7 over 1, $7 per shirt. So that means that our K equals 7 over 1 for our unit rate, which 7 divided by 1 is 7. So we have our equation y equals kx. I want you to write the equation down right now using k as 7. Okay, so you should have gotten y equals 7x. It's a little spotty. Y equals 7x. So now, just like before, we can use that to fill out our table. So $7 per shirt, and this is y over x. So that means your y is the $7. So y is money. And 1 is your x, which represents shirts. So y equals 7x. And if we plug in 5, we get y equals 7 times 5, which is 35. And then 7 times 10 is 70. And then y equals 7 times 15. And so I want you to go ahead and finish the table and the chart. So your x-axis is the shirts, and your y-axis is the money. Okay, so finish out your table and graph your points, and press play when you have finished. Okay, go ahead and check your table and see if it matches mine. If not, you may have just made a multiplication error, but just checking to see if that is correct. And then go ahead and finish your graph. Okay, and here is your graph. It is a straight line, it's linear, it goes through the origin. So to tell for proportionality, yes, it is proportional. And then let's explain how it's proportional from all three things. From the graph, table, and equation. Graph, table, and equation. So from the graph, we just said it. In order for a graph to be proportional, it needs to be linear, which it is, and pass through the origin, which it does. In order for a table to be proportional, it has to have equivalent ratios. In this case, we do. All ratios equal 7 over 1. And then for the equation, we learned that it is in y equals kx form. Press pause if you haven't written all of that down to make sure that you get it. And then let's continue on to the second part. So it says, read each scenario below and determine if the situation is proportional or not. So if it is proportional, then write an equation to represent it. And we're actually going to write it an equation even if it's not proportional. So it says, a restaurant charges $10 for a medium pizza and $1 for each topping. So I'm going to stop right there, and we're going to write on the bottom of our paper, per, each, and every. We have learned that per, each, and every mean to multiply. But not only do they mean to multiply, but they mean to multiply your variable. So this is where your variable exists in your equation. Also, proportional equation is y equals kx, and non-proportional is y equals kx plus b. Okay? Or mx plus b. So let's go back here. It says $1 for each. Remember, we just said means multiply, and then you're going to multiply your variable. So in this case, y equals the fact that it charges $10 for your pizza plus $1 per topping. Number 4, a restaurant has an all-you-can-eat buffet, and they charge $8.75 per means to multiply per person. So we don't see an and here. It doesn't have an initial fee. So this one is just saying y equals $8.75x, which means proportional. Okay, I want you to try number 5. Press play when you have finished. Okay, so you should have gotten y equals $1.50 per drink, which is $1.50D, or sorry, we could have written $1.50x here, which is proportional. And then a restaurant has a build your own salad option, which is $3.80 per means to multiply pound of salad. So y equals $3.80 times x. Press pause and finish. Let's change that to number 7 and finish number 7 on your own. Okay, so 65 miles per hour per means to multiply. So you're multiplying 65 times your variable, which is 65x, and it is proportional. If you have any questions, please make sure you let me know.